a little bit about the background of ICOPAL. It's been around for about 165 years. It was set up in Germany, which is quite intriguing because 165 years ago Germany actually wasn't formed then, so it actually precedes Germany, but it's headquartered in Denmark. And it's got a turnover of 1.2 billion. So manufacturing in 37 sites all across Europe, North America, and in the Far East. Basically, they are involved in all things, a sort of the core business, if you like, is bitumen products. But the three that are particularly relevant to what we're talking about this morning is their bitumen membranes, they're building acoustic membranes, and PVC bituminous membranes. So the three that are highlighted there. I'm sure everyone in the room is fairly familiar with noise, unwanted sound being transmitted through a separating wall or a separating floor. So I don't really want to bore you with the details there, but what I would like to say is that noise is really a health issue. You know, it is recognised that disrupted sleep patterns actually reduces your lifespan. So providing people with a good quality environment and a sound night's sleep uninterrupted by noise is actually a really important thing. And when we look at the detail, it's worthwhile just reminding ourselves that there are 13 different acoustic pathways when noise is created in a room. And that you've got the direct pathway through the wall or through the floor, but then if you look at through the floor, there are 12 pathways that either go from wall through floor to wall and back out, or room to floor to wall and back out, and all the various things. And because you see the arrows there, remember that happens on all four sides of the room, which is why it's all quadrupled. And the important thing to remember is that you can do what you like with the wall itself, but often it's the flanking transmission that becomes the limiting factor. It's the most difficult to deal with. We should also bear in mind that the construction industry is regulatory driven. You know, I wouldn't say it's impossible or totally unheard of, but most contractors, particularly in the housing field, do what they have to do. They're driven by the regulations. So we just need to recognise that. And of course, in what we're talking about here is sound. And of course, within the United Kingdom there, we have different regulations in different parts. Broadly speaking, they all add up to about the same. But the most important thing is we don't measure them exactly the same. But by and large, they're similar. When you're trying to be innovatory in building products, the first thing is you've got to spot your opportunity. And I suppose the best way to do that is if you find a need, and then if you can come up with a solution to need, you're well on your way to creating a product that's going to be marketable and be able to sell fairly well. A crucial element of that within product development is the technical compatibility. Our previous speaker, Dave, touched on it, in that when government introduces a regulation to do with thermal, it may have an impact on the acoustic requirement or the structural requirement or vice versa. So really, you've got to be very careful when you're starting to do things that what you do to benefit one area doesn't have a detrimental effect on another area. And that's actually quite important, and certainly it's something that we believe in strongly at Edinburgh Napier, is a team approach to this sort of problem solving. You know, it was nice to hear all the talks yesterday talking about trying to retain the ability to problem solve within the education system. And I think that is absolutely crucial to maintaining our place. So we have a policy where when we're working with companies, we go a team approach. So we'll have structural experts, acoustic experts, design experts, materials experts, whatever. We'll put together the team, because you never know when you enter a discussion with a company, where that's going to lead. You know, it can lead to other products or other things that the company hadn't even thought about at the start off, and it's only once they realise the range of abilities that we can provide at a university is that they start to get excited and engage fully. Of course, at the end of the day, having created your product, you have to make sure that there's a cost-benefit analysis done to see that your product is going to, at worst, be compatible or comparable in cost with other products on the market, but generally speaking, you're looking at something that's going to be cheaper and work better is the ideal. Dave had a slide up that showed the issues to do with separating cavity walls sitting on a continuous foundation. Now, before we came up with the concept of bridge stop, that was Edinburgh Napier and ICOPAL. The issue here was that mortar build-up in the cavity created a direct path through the wall, so it was not a good idea. The alternative, so you really weren't allowed to build a raft foundation if you were going to build that cavity wall. But if you split the slab and take the cavity down below to say a strip footing, if you're building on a brownfield site or in a radon gas area, you end up with a radon barrier. The radon barrier has the same problem. Dave's touched on it already. The mortar just builds up on the radon barrier, and if it's not cleared, it's a problem. If you try and clear it, then you've got always the possibility that somebody accidentally damages a radon barrier, which is probably an even worse situation, because that is another health issue if that's damaged. So we looked at coming up with a solution to that, and that's bridge stop, and that's just a couple of sheets from the publicity material for ICOPAL's bridge stop. There's a little bit of a better image of it. And what we came up with there was actually the concept of, first of all, using a damping membrane under the wall to separate the wall from the raft foundation, so that you're attenuating the sound from the wall as it passes into the slab, and then you're attenuating again when it comes back into the wall on the other side. And that got rid of a good element of the flanking transmission. But then we had to address the issue of the mortar build-up in the cavity. And it's always amazing to think that at the bottom of cavities you can get over 300 millimetres of mortar droppings built up when you build a wall. We all know, as architectural technologists, the cavity should be kept clear and clean at all times, etc. But we also know that it is a problem. It's a difficult thing for builders to address. So we took the approach that we would accept the fact that there would be mortar droppings coming down. So we had to isolate the wall from the mortar droppings. So we, in discussions with ICOPAL, they come up with a nice soft resilient foam made from recycled foam. So it's a recycled product. And we designed these special clips, which are just push-fit connections that once you push them in, they can't come off again. So that we can essentially drape the bottom two courses of the blockwork with a resilient layer, so that we can actually build up to about 400 plus level of mortar droppings, and it will not adversely affect the acoustic performance of the wall. The other thing to note when you see the little, and they are that bright pink plastic, the depth, if you'd see the ends, there's one fixed end and there's one push-fit end, but the thickness of that is quite critical as well, in that we designed the thickness of it to be the thickness of the parge coat that Dave talked about when he was talking about robust details on a separating wall. So if it's installed and the wall has been parged correctly, then the little big pink marker should just be flush with the plaster. If they're hidden, well, that's some ways it's good because there's probably more parge coat on it, but you would then need to make sure that had been installed at all. But provided they've been installed, it's a real indicator so that when you see it, you know that the wall has been parged to the correct depth. And it's nice when you can develop products which actually help another process in the way that it's done. So there's the detail there. And this all came out from us realizing that there's a problem, and we wanted to address that problem and help builders be able to build cheaply or more economically on brownfield sites. And that was a major element. I was going to say the interesting thing, the third point down there, is that we did quite a lot of the development work on a train journey between Edinburgh and Manchester, which is ironically a bit like they putting this presentation together yesterday on a train journey from Edinburgh to London. But we got a lot of really good cooperation with ICOPAL, were really helpful, but also one of the major builders in the area of Fairclough Homes were keen to take on, and they tested it for us on building sites, so that it was proved to be able to work. I don't think I really want to add too much to that. In terms of its performance, it was the first. I know that the Code for Sustainable Homes is no more, but it was the first 4-credit wall for the Code for Sustainable Homes. So it was a really high-performing wall in an area where it hadn't been possible to do one at all in the past. So it's a really big step forward. It's got robust detail status, and it was shortlisted. Unfortunately, it didn't win, but at least we had a nice dinner in London when it was shortlisted for the Housing Innovation Product of the Year in 2009. I believe there's about 100,000 metres of this installed throughout England and Wales. So there's about 10 kilometres of separating wall. Now, that's a big separating wall. I hope it's not just one building and it's spread over many properties. And that's just all the acknowledgements for the people that were involved. See Lee Nichols there, other people from ICOPAL, and one of the major house builders. When we were working on that, we decided that the results were so good for the resilient layer, the damping membrane between the wall, we decided that this might be a good inroad to do other products that would be able to help reduce the flanking transmission from apartment to apartments vertically, where you've got, say, precast concrete floors sitting on masonry walls. Could we introduce a similar type of resilient damping layer between the wall and the precast concrete slabs? So we put together our thoughts, we applied for funding, and we were pleased that Scottish Enterprise were able to award us funding for the proof of concept, which was the first proof of concept for construction. So that gave us some money to develop the product further, or a sister product to the bridge stock. And we come up with what we call wall cap. And again, we work with ICOPAL, so it's part of ICOPAL's suite of acoustic products now. But when we got the funding from Scottish Enterprise, we were able to go and release not much funding as such, but we were able to encourage and cajole other suppliers to provide us with masonry, with precast concrete slabs, with timber I-joists, etc. And we used part of the funding to develop a test facility, and it was euphemistically known at the time as Hangar 17, because it was all hush-hush and it was in the depths of Fife, across the Forth Bridge, which is now cut off from the rest of Scotland because of the defects on the bridge. But we developed that facility, and we used the funding to build some test apartments, because when you're developing products, it's quite difficult to test them, because once you start installing them on building sites, everyone gets to know about it. And until you've got your patents through or you've got your product ready to be launched, you don't really want too many people knowing what you're up to. So we started off by building some blockwork apartments, just 6 rooms essentially. We're not talking about complete apartments here. It's 6 rooms, 3 in the ground floor, 3 in the first floor. And then we followed that up with some timber buildings. And interestingly enough, at the same time, the problem of convected heat in cavities and separating those walls was starting to become known, because we're doing this in parallel with Leeds Metropolitan University. Professor Malcolm Bell there was looking at the Stamford Brook project, which is looking at co-heating tests and all their properties to find out what the performance gap between the design performance of a dwelling to the real performance, the measured performance of the dwelling. And at the time that this was all current, we had a very cold spell, and that's Edinburgh that you can see in the image there. You can see the Pentland Hills in the background. What I'd like to note is that's not snow, that's frost. So that shows how cold it was. It was about 10 degrees below freezing. It was one of the coldest spells that I've ever experienced in Edinburgh in my lifetime. Very, very cold. And what it demonstrates clearly is the convected heat loss in the separating walls. You can see the big black stripes on the roof where the heat's coming out. And the intriguing thing for me is when Stamford Brook study, Leeds Met now, Leeds Beckett, they actually established, or were able to work back from the co-heating test as to what the U value was for that separating wall, or for a separating wall in a terrace dwelling. And if we think of trying to build, say, external walls at, say, 0.2 of a U value, they calculated that the U value of the separating wall was coming out at 0.6. And in a row of terrace properties, that means that 4 times the amount of energy is being lost through the separating wall than through your outside walls. It's a big, big issue. And that's why the regulations were changed, SAP calculations were changed. We've got full fill cavities or an effective edge sealing required. And of course, what we were able to do and looked at was, could we create a product that could not only give you a better acoustic performance, but actually help the edge sealing and actually help the thermal bypass situation that you're getting in the cavity. So those are just some, you can see we're inside just a basic factory unit, a spec-built factory unit that was leased. And you can see we're building the masonry blocks there, and you'll notice that on one end we've got dense block, and we've got lighter weight block at the other end. And a couple of them have precast concrete slabs over 2, and then we've got I-joists over the third unit. So we can actually test through concrete floors from dense block to dense block through a concrete floor, lightweight block to lightweight block through a concrete floor, and through a timber floor, essentially. And then you've got the separating walls that we can test between them as well. So we built those, and we installed the wall cup product in it, and it was so successful we then managed to get some extra funding, and we built some timber ones so that we could see if we could improve the performance of the timber ones as well. That's it. 1 minute. Okay, I'm pretty well finished. This is a little mock-up that we did of a masonry cavity wall, but only built partly, so we could see the cross-section of it. And the thermal image on the left shows heat being transferred up the cavity with a cavity fire sock in place. And the one on the right has got the wall cap installed, which shows that there's much less heat being convected up the cavity because it's effectively sealed. Because although the fire sock is there and it's a fire protection, it doesn't seal 100%. This product was also nominated, shortlisted for the Housing Product Year. Again, we didn't win, but we did get another nice dinner in London. And finally, on the back of all the research we've been doing recently, in timber engineering and timber design and off-site construction, we are proposing to launch another master's programme that's going to sit alongside the Masters in Architectural Technology called Masters in Timber Architecture. And it will have wood science, so you would actually get a qualification as a wood scientist, and you'd meet the entry requirement for that. It'll be heavily based on our experience of off-site construction, building performance, timber properties and timber design. So that's what we're planning to do, and I just wanted to finish on a nice building. That's the Dune House. Some of you may know it. It's in Suffolk. It's for rent. It's a holiday cottage, and if you've got £750, you can have it for 3 days. And it's a beautiful building. The reason I put that one in, it's cross-laminated timber, but only the first floor. The roof and the upstairs is cross-laminated timber, and it all sits on a glass box. There are obviously a core and some columns inside, but it's all CLT sitting there. So not all timber buildings need to be basic. We can do some really exciting things with timber buildings. And my final point is that there is a major manufacturer in Scotland who is currently investing a lot of money in developing a production plant for cross-laminated timber from homegrown timber in the UK. So as specified, you'll all be able to use homegrown CLT some stage in the future. Thank you.